And welcome to this video. I want to cover a basic practice part in SolidWorks, and here we've got some of the dimensions. So I'm going to go ahead and start a new part here. And the first thing I'm going to do is probably sketch out just the basic footprint of this part using the dimensions that we have here in this trimetric or isometric view. I'll start by making a sketch on the top plane, and just as a reminder to orient on the top plane, when I am normal to the top plane by pushing Control 8, that should be my top view of the part. And the reason that that is important is because we use that for drawing orientation. We make a drawing of the part later on for good design practice. So I'm going to start by making a sketch, and I'll start by making notice I've got 50 and it looks like 20 on each side. So I'll make my width of 50 plus my 20, making it 70. I'm going to make a line. In fact, I can even make a midpoint line. And another line. And the reason why I didn't make a line that was simply 70 or even 90 long was because I want to be able to center and have this as a reference point later on. Okay, so I'll add some dimensions. 50. I'm sure this isn't millimeters, but I'm going to just keep my default units for ease of editing later. So this will just be 25.4 times larger since I'm in inches, but the dimensions are relatively arbitrary for this exercise. I can add in my other line because of course the other side, as would be implied geometry, is the same. So I'll add in equals over here. Now I will add in a tangent. And make this also tangent and equal. Very good. Now I can float around here quite a lot, so I'll take my midpoint and make it vertical to my origin. So if I want my center to be dead center, then I'll simply take this arc and make my origin horizontal. And now I have to know what radius this is because I can freely move this arc radius. And it looks like this radius is 15. Great. Now from here to here is a radius, or I can just click on the body of the arc. Either way is fine. Now I could probably take another easy route and mirror. If you're not comfortable mirroring, feel free to simply sketch the other side, and that would be just as fine. I click on Mirror Entities, and I choose here, and I mirror about this line. Now with this footprint sketched, I'll make a line out here. And now I see that my overall length is 40. And I can extrude this to a given height. My given height appears to be 10. And we have extruded to a given height of 10. Now there's a few ways I can go about making this next feature. I think the easiest for this video would be to just make a straight extrusion and then cut in the triangular feature. So to do that, click on this face and choose Sketch. Now I know I have a few things I'll highlight this line and say Convert Entities, which creates a sketch along this edge. I can also just get a line and click on these two corners if I would prefer to do that. Now I can choose a vertical line, come over here, and that gives me a basic footprint for this extruded feature. I'll extrude that to a length of 60. Again, this is probably in millimeters. I'm using inches. Okay, now I've aligned relative to the planes in a way that my right plane runs through the center of the part, so I can make a sketch on this plane center here. Very good. I push Control 8 to get normal. And my triangular feature looks something like this. So when I extrude this, I will be cutting out material with regard to this sketch. In fact, I could probably even Control 7 and look at some of the dimensions just like how I'm looking at it in this view. So from here to the bottom, I've got 10. Again, click on this corner. And from here to this edge, it looks like I have to click on this corner. I've got 10 again, and we're fully constrained. So the question is, what is this distance? Well, 10 and 10, and this gives me 30. So I'm going to extrude this 30. And I'll do that mid-plane. Now I've got a whole feature to work on. So I'm going to sketch on this face, and notice that these faces are coplanar. And so what I do on one face can equally be level with the other face. So pushing Control 8 to get normal. It looks like it's assumed that these holes are concentric because I've got the radius points that converge on one point. So I can click that point that's concentric with the outer arc and do the same over here. Make these two equal and apply a dimension. This will be a diameter of 10, and we'll then say features, extruded cut, and through all. And there we have the part that we see in the view. I do see one error that I would like to fix. I had extruded this to a height of 60 because I read the 60, but I forgot that we'd already extruded it to 10, so this should be 50. And I believe we've got a nice apples to apples comparison. If we wish to compare, we can move to SolidWorks MBD. You can even right click on this menu and activate MBD. I don't know if you need an extra license for this or not, so I don't know if this is available on all systems, but for a quick apples to apples check, I'm just adding some arbitrary dimensions. It looks like 60 matches, 40 matches, 50 is good. $10 is good. Some of the other dimensions they give 30 right here. And we've got 30. We've got 10 right here. So every dimension appears to be matching beautifully. We've modeled this correctly. Thanks for watching. If this was helpful, please subscribe. That is the best way to help me back. And I'll catch you in the next video.